Welcome to my lecture series. So in this video we discuss about semiconductors. So semiconductors are materials whose electrical conductivity lies between that of conductors and insulators. So the conductivity of semiconductors is in the order of 10 to the power 4 to 10 to the power minus 4 mho per meter. So it is a special class of material, so very small in size and sensitive to heat, light and electricity. So semiconductor materials become insulated at low temperatures and conductors at the high temperatures. So in this video we discuss about what is semiconductors and p-type and n-type semiconductors, and what are diodes and forward bias and reverse bias and characteristics of ideal diode and IV characteristics of diodes and rectification. So the resistivity of semiconductor is lesser than the insulator but more than that of conductor. So it is called as that semiconductors. So it is in the order of 10 to the power minus 4 to 0.5 ohm meter. A semiconductor has nearly empty conduction band at almost filled the valency band. So the very small energy gap, that means 1 electron volt. So we have seen that the metals additions are impurity, so well as the rise of temperature result in the decrease in the electrical conductivity. So whereas in semiconductors the electrical conductivity increases. So zirconium and silicons are the important element semiconductor used in manufacturing of diodes and transistor. So gallium arsenide and indium phosphide are the important component of semiconductors as used in LEDs and laser diodes. Properties of semiconductors. So the resistivity of semiconductors lies between that of the conductor and insulator. So at a 0 Kelvin the semiconductor behaves as a insulator. So in semiconductors both electron and holes are charge carriers. So the impurities are added, it will increase the electrical conductivity so of semiconductors. So if we increase the temperature of semiconductors, its electrical conductivity also increases. So the semiconductors are based on the composition. So we have they are classified into two types. So they are elemental semiconductor, another one is the compound semiconductor. So elemental semiconductors are simply is made up of single element. These semiconductors are from the group of 4 elements in the periodic table. So already we know about that. They have 4 valence electrons in their outermost cell. So they are also named as the indirect bandgap semiconductor. And then compound semiconductor, the compound semiconductors are made up of 2 or more elements. So the compound semiconductor belongs to the 3rd and 5th group of elements and also belongs to the 2nd and 6th group of elements. So these are also named as the direct bandgap semiconductor since recombinations of electrons and holes takes place directly leading to the emission of photons in the visible or infrared range. So since the lifetime of the charge carriers is very small, so the current amplification is small, hence they are not suitable for making a transistor and ICs, and they are used making LEDs and laser diodes. And based on the purities, the semiconductor classified into 2 categories. So one is the intrinsic semiconductor, another one is that extrinsic semiconductor. So intrinsic semiconductors, so semiconductors that are free of doping impurities are called intrinsic semiconductors. It's an extremely pure form. That is, so the extremely pure form is called as that intrinsic semiconductor without addition of impurities. So for example silicon and zirconium. And so we know the germanium and silicons are the 4th group of elements of the periodic table. So the germanium has 32 electrons and silicon has 14 electrons in their atomic structure. And the semiconductors like zirconium and silicon have a crystalline structure. So both the semiconductors are tetravalent. So each has a 4 valence electrons in the outermost orbit. So in the case of pure germanium, out of 32 electrons, and 28 electrons are tightly bound to the nucleus. So while the recombination, see the diagram. So while the recombinations evolve in that outermost orbit, so these 4 electrons known as that valence electrons. And in the case of silicon, out of 14 electrons, 10 electrons are tightly bound to the nucleus, while the remaining the 4 electrons evolve in the outermost orbit. And let us consider the case of two atoms or germanium and brought close to each other. So now the positive core of one atom interacts with one of the valence electrons of their atoms. So each core interacts with one of the valence electrons. So each core attracts the electrons from the other atom, and 2 electrons are shared by the 2 atoms. So when the attractive force are balanced by the repulsive force, and then between 2 positive force covalent and bond is formed. So therefore at 0 Kelvin no free electrons are available for conduction. So hence that the semiconductors behave as then insulators. So to get a free electrons, covalent bond must be broken. So there are many ways breaking the covalent bond. Sitting the electrons are free. So one such a way that the increase in the crystal impurity temperatures above 0 Kelvin. So therefore that in a semiconductor both holes and electrons are charge carriers, and the current transport is effectively taking place in the holes and electrons. So thank you.